Now I am going to talk about three most important derivations or questions of Huygens wave theory. Just check whether you know these answers. If you know these answers, then certainly you should write once so that you can be confirmed that you know the answers and you can write them well. And if your preparation is not good, then don't panic. Just pay attention on the most important questions which I am continuously uploading on the series for semester 2 exam class 12 ISC, and try to prepare those important questions so that your question paper is up to the mark. Now, Huygens wave theory postulate. I hope this is an important question, probable question, and how to write its answer. You will first write point that light travels in the form of waves. This is the first point which he said. Then he proposed geometrical construction method to explain the propagation of light, and in that the geometrical construction method he said that at a surface in the medium, according to him it was ether, at which the surface at which all particles lie in the same phase of oscillation is called wavefront. Now wavefront is important definition, it's a separate question, equally important. Then second point in the propagation of light mechanism is that every point of wavefront acts as a new source of light wave from which new waves called secondary waves or wavelets originate. Then third point, according to him, secondary wavelets travel in the medium in all directions with the speed of original wave. Then envelope of secondary wavelets in the forward direction at any time gives position of new wavefront. Now, if you don't have the clear concept, then just go through these points and try to learn these points. Otherwise, the total Huygens wave theory is already uploaded, and if you want, you can go through the concept also. Then remember that wavefront is always perpendicular to direction of propagation of light ray, and if the light source is point source, then its wavefront has shape of concentric spheres. If the rays are parallel, that means the source is at infinity, then wavefront has shape of rectangular plane parallel to each other. And if it's a slit line source lights, then coaxial cylinders are the shape of the wavefront. Remember these three shapes for these three light sources. So here not only we covered the important question of Huygens wave theory important points, we also covered the 1 marks question or 2 marks question which can be asked from this part. Now the two next very important and according to me laws of refraction. For this year, laws of refraction is the most important derivation from this part, Huygens wave theory. So let us go through the laws of reflection using Huygens principle, proof of this part, and laws of refraction also. So if laws of reflection you have to prove, then we draw two lines representing incident ray on a surface which is a reflecting surface, and then we draw a line perpendicular to these two lines which will represent the wavefront AD. So instead of saying that two parallel lines are incidenting, the two parallel rays are incidenting, if we are using Huygens wave theory, then we will say that wavefront AD is incidenting on the reflecting surface. This is what is called using Huygens principle. Then AD is incidenting and perpendicular to the two reflected rays. BC is the reflected wavefront. So what we will say that AD is incidenting wavefront and BC is reflected wavefront. After that, we will use geometrical mathematics to prove the law of reflection. Now pay attention on the geometrical mathematics only here. See, this is incident ray. So angle between incident ray and normal is I. Since this is 90-degree angle, so this angle is 90 minus I. Now this is reflected ray. So angle between normal and reflected ray is R. This is 90. So this angle is 90 minus R. Now we just go with these two angles in the next step. Just remember that wavefront is perpendicular to ray. So this is 90. The incident wavefront is perpendicular to incident ray. So this angle is also 90. So now we are going to consider this triangle and this triangle. Now observe both the diagrams. In this triangle, this is 90 minus R. So here see, this is 90 minus R. This is 90. So this is 90. Now just observe in this triangle, 90 minus R. So this angle is R. Again compare these two, this triangle and this green triangle. this is 90, this is 90, this is 90 minus I. This is 90 minus I. So 90 minus I, just observe I. So this is 90 minus I because this was 90 degree. This is 90 minus I. So obviously in this triangle, this will be I. Now we put all the necessary angles in these two triangles. One triangle made by reflected wavefront and one triangle made by incident wavefront. Up to this part, this whole logic was to understand the things. You don't have to write all these things in your copy. If you got the logic, then this is the part which you should write in your answer copy. Here, we will consider the triangle made by reflected wavefront and triangle made by incident wavefront. And these two triangles, one which is the yellow one and one which is the orange one. So in triangle ABC and ABD, these two angles are 90 degree angle. Then AB is common. Now consider this point D of the incident wavefront. It is moving with the speed of light if it is the air medium, and in t seconds it reaches from this point to this point. During this time, when D incident part D reaches to point B, the part which is already incidented on the reflecting surface A of the wavefront, that is reflected in the same time to point C. Since medium is same, speed of light is same, so this distance is also speed of light into time t, and this distance is also speed of light into t. So these two sides of the triangle are equal. So these three conditions say that the two angles are congruent and therefore the corresponding angles will be equal. So we proved that angle of incidence is equal to angle of reflection. And since all the rays and the normals are on the plane of paper, so the first law of reflection is also proved. So this is the proof of laws of reflection using Huygens theory. Now according to my guess, proof of laws of refraction using Huygens principle is very, very important this year. So just observe the two rays incident, but we will talk in the terms of incident wavefront. Then the rays are refracted because the speed of light in this medium and speed of light in this medium is changed. So the rays are refracted here, but we will talk in terms of refracted wavefront. So this is the incident wavefront which is perpendicular to incident ray, and this is the refracted wavefront which is perpendicular to refracted ray. While drawing the wavefront, you just observe that this point is the point which is first incidenting on the refracting surface. So this point with velocity v2 in the medium 2 will move to point D if you consider t seconds time. And in t seconds time, let point C reaches to B. And here the light's speed is v1, in the medium 1. So when A reached at point D, C reached at point B. So incident wavefront will have this inclination, while refracted wavefront will have inclination like this. Just observe the logic, then only you can remember that why this wavefront is drawn like this and this wavefront is drawn like this, because this will move to the point D till the C moves to the point B. Now again we will use the geometry. Observe angle of incidence. Now since ray and wavefront are 90 degree, so this angle is 90 minus I. Now this is 90 degree, so this is 90 minus I, so this angle is I. And wavefront and incident ray at 90 degree angle. So yellow triangle we have the two angles like this. Then in pink triangle, the angle of refraction is R. Now this is 90 degree. So this angle is 90 minus R. Wavefront and refracted ray are 90. This is 90, this is 90 minus R. So angle of refraction R will come in this pink triangle here. Now this proof is much simpler than the laws of reflection. Actually, if you got the logic, then you just have to write the Snell's law that says that sine I upon sine R is a constant, or speed of light in first medium divided by speed of light in second medium. So sine I, just go through this triangle. Sine I is perpendicular upon hypotenuse, that is BC upon AB. Sine R is perpendicular upon hypotenuse, that is AD upon AB. Now what is CB? CB is speed of light in medium 1 into time t during which C reaches to B. What is AD? AD is speed of light in medium 2 into time during which A reaches to B. So this is V2 into T, this is V1 into T. Substitute these values here in place of BC and AC. And you got sine I upon sine R is equal to AB is cancelled here and T is cancelled here. V1 upon V2, speed of light in medium 1 upon speed of light in medium 2 is refractive index of second medium with respect to 1. And since all the rays and all the normals are in the plane of paper, so second law is also automatically proved. So this is all about wave theory, Huygens wave theory, and you must get 1 or 2 questions from this part, which according to the last 15 years question paper pattern, I guess.